So, the first presentation, I think that's not the first slide. There. Yes. So, the first presentation by Bartlomiej Weglarz. Bravo for him. So, the first presentation is about Apache Ignite, the nice introduction. Passing to you.
Thank you, Krakow. Okay, so as you can see, my name is Bartlomiej Weglarz. My official role in Grid Dynamics is Big Data Architect, but what I do is basically software engineering and coding, but I sometimes have a chance to take some decisions, so this is the good piece. But I can influence some things, and it's not only the coding, but it comes with more responsibilities sometimes. So I have to pay the price for that as well. So just a few sentences about me. Around 15 years of experience in IT. It's a little bit more, but 15 looks nicer. I've been working with Grid Dynamics for the last 2.5 years. I came here from Allegro. The reason for that was that I was asked to build big data skills in Grid Dynamics, help people move from, let's say, enterprise Java or other systems, and build some skills around Hadoop ecosystems, Spark, Kafka, and all those technologies that are today seen as the big data space. Previously, I worked in IBM in Krakow, and then I also worked in Dell in Dublin. I think this is where I started working with Hadoop and the open source ecosystem. That was around 2011. I spent there 2 years. So the agenda for the presentation is I want to tell you why I think it's interesting to talk about Apache Ignite. I want to tell you what it is and basically how it works, and show you some really simple code examples. It's not going to be rocket science, like some machine learning stuff, but just to give you highlights of the basic components, how difficult or how easy it is to use the mechanisms that are built into Ignite. And the last thing, I just want to list a few other in-memory data grid solutions so we have some idea what we have on the market. Some of them are open source and some of them are commercial, so you'll see what it is. So why Apache Ignite? So as I said, like 2.5 years ago, I joined Grid and I got my first assignment. So I think this is where the architect role comes in. So I got contacted by our customer, and they had an idea to build a new system. So they are a digital marketing company. They buy data in the US, pretty rich and big data. I would call it maybe not big, but region extensive. The way they work is that they have information about every citizen in the US. So it's around 280 million people, roughly 300 million people, and they have data about each person in a way that they can tell if it's a male, female, if they have a sports car, where they live, and things like that. So they describe every person by a set of attributes. And what they wanted to do is that when they build advertising campaigns, they want to give their business people a tool that would let them select the right people to which they should target the ads. And this tool should be pretty fast. So they wanted to build some queries, like just imagine in a SQL world where we live in as well. Like you do a select with a big where, and then you have group bys. But just imagine, like, I don't know, 20, 30, 40, 100 group bys, and the filter can grow. And they said, you know what, we want that query to be run, and we want the response within a single second. No matter how many attributes we put, and no matter how many group bys we don't have. So this is like the front end of the tool. Yeah, I think it doesn't look that bad, but the idea of the system is as I'm showing right now. So you see the base on the right hand side over there. So this is the size of the population we have. 277 million people. On the left-hand side, you get a set of attributes. I think I could be scrolling, but you see the progress bar over here. This is like 8,000 or 10,000 attributes these days. We started with 500. So this is, when I was starting the project, they said about, today we have 500 attributes describing each person, but in the future we can have more. The important fact is that these are all like Boolean attributes. So for a male and a female, you have 2 attributes. Well, initially we had that situation that we have both male and female set. We kind of discovered that maybe it's wrong, but these days you never know, but it was wrong. But this is the kind of data. If you scroll and look at it, they really have rich data. They buy that from different companies, and they can really well describe a single person. Of course, it's not assigned here to any ID, so you can't tell that this person likes that or that, but just gives the statistics. So the tool as it works is basically the guys sit in front of the UI and they do something like this. Find me all the people that drive Lexus, fine. And just look at the numbers on the charts over there. They keep changing with every attribute that I add. So I wanted, let's say, female, and then green living, so they're interested in healthy lifestyle, and let's say that they check prices on Amazon. So all of the statistics that you see on the right hand side keep changing with every attribute that we add. So all of that is supposed to work within 1 second, and this is how we build it. So I started my evaluation. This is the nice part of being architect. I was given some time and I was told that I can evaluate different technologies for thinking what might work for us. Well, the first idea that probably comes to your mind is, why don't you use Elasticsearch? Yeah, it kind of works, and the results were pretty good. But the other requirement that we had was that, well, it's supposed to work on AWS. And this is kind of an issue, I would say, at least for me, because when you go to the cloud, like, you never know what to expect from the I/O performance, especially in the perspective of disks. Because if you go to AWS or Google Cloud, especially Google Cloud, have various ways of attaching your disks. They claim they are SSDs, but they're not. They still work over network, so you never know what to expect. And the other argument for not using Elasticsearch was that, well, at least one, that these attributes keep changing. So we started with 500, as I said, not a lot. Next month we had 2,000, then 5,000, and today we run around 8,000 or 8,000. So if you think about it, like every time you get a new data set, you'd have to change your schema, index the files, rebuild it, and all of that schema management becomes a pain. Whoever has done that with like SQL databases, you know that you have to keep backwards compatibility, forwards compatibility, and then nobody knows what you run in production or in test, and it gets really messy. Another reason for not using Elasticsearch was that I heard that the future requirements will be more, you know what, we want to have aggregations, but there will be custom aggregations. We don't know yet how we're going to calculate those values, but we'll provide you with an algorithm sometime in the future, and you have to implement it. So you can do that in Elasticsearch as well, but imagine plugins in Elasticsearch with some DSL. I don't think it's cool, and I don't think I would quickly find people who would like to do that, because it looks like, I don't know, some groovy thing. Yeah, you can find some people for doing that, but not a lot. Some people enjoy it, not me personally. So I thought, let's try something else, and this is how I came up with an idea of using in-memory data grid, which I had never used before, to tell you the truth. So I started my evaluation, I started playing with Ignite, I started checking what the performance might be, and there were a lot of tricks that we had to do to get to that stage, but this is what can be done with Ignite. It's not just a search. I'm just showing you the front end. There's a lot of things happening in the background. We have a lot of exports, quite sophisticated with filters. We do a lot of crazy things to support some of the scenarios, but the nice thing is that this whole component lets you build a lot of features by means of the mechanism or the components it has inside. So I'll stop with this and I'll go back to my presentation. Then I guess I'll have to switch to my computer. So what Apache Ignite is basically a distributed system, but it can be a database, it can be a caching layer like a memcache, and it's also a processing platform. So you can imagine you can do a lot of things with that depending on what you want. I know that you might think that a generic tool will not be good, and I bet that it's not, this database is not better than Cassandra in terms of writing, or not better caching than memcache. It all depends on your scenarios, how many writes, gets, and what kind of throughput and what kind of high availability and fault tolerance you need. So I'll try to describe all of those, give you an idea, and show how to code some simple examples, so that if you have some time or you're lucky enough, it's your job to pick up some technology, maybe you'll use it. It's not a very famous technology, that's why we came up with the idea of presenting it, but I bet that you've heard about some others like Hazelcast. I think they're doing more marketing, and I guess they're better known in the world a bit. So just imagine a set of computers with Apache Ignite, that they can discover each other. How? Well, they can discover each other via multicast or static IP addresses in the same network. They can discover each other via some Amazon S3 or Google Cloud Storage or any file system. You can use some JDBC adapter and store the discovery engine in a database. So this is just a registry of the computers within the cluster. When they start up, they look for each other in that repository, and then they start talking to each other like peer-to-peer system. And you can also use Zookeeper. And out of the box, you also, when they discover each other, they keep sending heartbeats to each other, so they know which nodes are up, which nodes are down, and you have the consistent view of the whole cluster. So this is what you get out of the box. I know it doesn't sound like very great, but this is what you start with, and this is where you can build more mechanisms. So I'm showing you some picture that I took. That was January 2018, old one, but see the topology snapshot, I believe. Yeah, like you see it's version, what is that, 55? Yeah, so that means that, you know, there were 55 events in the whole topology of nodes joining or leaving the whole cluster. So we used to have 42 servers running. We had 354 CPUs, and we were using 2 terabytes of Java heap space distributed among these 42 servers. That's, I would say, it's quite decent. And this picture, the bottom down, is taken from a tool called Ignite Visor, which is also part of the distribution. I'm going to run that soon so that you can see how to start with Ignite. So let me switch to probably, for some of you, an old school IDE, which is Eclipse. Yeah, I'm not gonna have that conversation about IntelliJ and Eclipse. Forgive me, we can do that later. Okay, so I want to start an Ignite server. Okay, so I have a Maven project. Yeah, it's not great or something else. It's just really simple. So you just put 2 dependencies, Ignite Core and Ignite Spring. The bottom 2 are not important at the moment. So you use those 2. The Ignite Spring is just for configuring your cluster. So My simplest configuration is just to let Ignite know that they should discover each other via multicast IP. I have some limitation over here because there were times when I was not using that and another person joined my team and I was loading his cluster and he was loading my cluster. So we decided to limit that to local hosts just to keep it safe. So basically, if you want to start an Ignite server, you just call ignition start with the path to your server config. And the server config is not much different from the config. You just include, for instance, the config cache, and you say that the client mode is false. That means that it's a server. The difference between the client and the server is that the server can hold caches that I'm going to cover later on. The client should be just a lightweight thing that talks to the server's cluster and does a few things with the cluster. So let's start it. Okay, one instance. Let's give it another two. And I want to show you the topology things, changes that are going on over here. So this line you can see, like out of the box, we have version 2 of the topology, yeah, because there were two servers joined, so it keeps increasing. We have 4 CPUs because I'm running on the same box. So CPUs do not like that, but the heap is growing, both heap and off heap. So it's that easy, and this is how you can run your Ignite process from an IDE, but you also have a choice to download. That's too small, I guess. To download zip from Apache Ignite webpage, just unzip it. You get a folder like this, and in that directory you have, for instance, a tool called Ignite Visor. This is a kind of monitoring tool that is part of the distribution. Well, you might not need it, but sometimes if you go live to production and you want to jump to a server and just see what's going on, you just basically run it, and you don't need UI or anything like that. So just type top, and you see that I have total nodes 2. It's just one host. So it gives you rough statistics about the topology of the cluster. You can run other commands over here, but this is boring, I guess. So let's go back over here. When I was showing you the Maven configuration, I skipped those 2 things. So I'll skip again this one. But the Ignite REST HTTP is a fairly decent one, because once you include it, you don't need that Ignite Visor. Sorry for that. You don't need that Ignite Visor. You can basically use like a REST API. You talk to a node, and I'm just saying the command is top, so give me the topology. So it's going to give you 2 nodes. And since my config, not the one that I was showing, so I lied a little bit, contains 2 cache definitions, it's gonna list those caches over here. There are other commands that you can do over here, and Alex will be showing what we can do with it. So let me go to my Eclipse, and I'll show back the real config file that I have, so just to give you an idea. So basically, in the Ignite configuration, you want to say that you want 2 caches. So we have the test cache and person cache. I'll talk about different caches in a moment, but this is how what the configuration looks like. It's really simple, and starting a cluster takes you a minute or 2. And if you use some other tools that Alex will be showing, maybe it's going to take you even less time if you don't want to download anything to your box, but just some virtual images, some Docker files. Yeah, it's doable as well. So that's it with starting the cluster. Let me go back to this presentation. So I want to talk about 3 out of the multiple components over here. This picture I've taken from the Apache Ignite side. I think they have more components, but I want to talk about the data grid, the compute grid, and SQL grid, even though I hate SQL, but apparently all people like to have a SQL interface to any component that you can think of or software, so yeah, why not? So the data grid. So the data grid is basically an in-memory distributed key value store. So it's a distributed hash map, by the way. And then one of the differences between Apache Ignite and Hazelcast is that in Hazelcast, a cache is exposed as a map interface in Java, so you can easily replace your in-memory local JVM maps with Hazelcast clusters. I don't recommend to do that. Seen crazy problems where people didn't know they were using a cluster, not just a single JVM. And Ignite, it's not just a map. Like, it works like a map, but it has a different interface, so it doesn't let you convert that easily. So one of the most important features of such a distributed map is to determine where each data should be stored. So there's a pluggable algorithm in Ignite. You can plug in anything you want. But by default is something called rendezvous hashing. It's an interesting and simple algorithm. I'll talk about it later on. It's really simple, so it won't take much time. Ignite supports 3 types of caches. It's local, replicated, and partitioned. Local is not very important, I would say, because it's just stored on a single box wherever you put it. It's like a map, but without a map interface. The replicated and partition caches I'll cover in the next slides. Another interesting feature is that when you have that cache, the cache can be kept on heap in the Java heap space or off heap. Starting from 2.x, Ignite decided not to have on heap caches. Like, I'm just guessing they got in, like, their customers got into the same problems that we did. Like, last time I remember we were running our nodes to 44 nodes or 42 nodes. We were using 48 gigs of heap, and I think 36 of gigs were constantly busy. So if you think of the garbage collection starting and taking full GC, it's gonna take a while. So I presume people complained about it and they just ripped off the on-heap cache and left the off-heap. It can also use a persistent storage for the cache. So this is where it becomes a little more like a database. So this is an interesting piece. You don't really have to store all the data in memory. I can put into the cache and mark the cache as persistent. I'm not using that in my configuration, by the way. But that's the interesting piece, because you have a support for eviction and expiration policies. So you can tell it which objects and when should go out of the cache. If you can support, I don't know, just a limited amount of memory, just remove it when the cache reaches, I don't know, 10 gigs. Or when the objects get older than, I don't know, 2 hours, just get rid of them. So that's a really nice feature, I'll say, combined with the persistent storage. And it also supports ACID transactions, which is sometimes very important for e-commerce or enterprise companies, because they really need to have consistent view of the data, even though it's a distributed system, and sometimes it's really hard. But at the moment, there's no ACID transaction support for SQL, and I know they're working on that because it's not trivial. So let's go to 2 types of caches that I mentioned. One is a partitioned cache. So if you have any distributed system like Spark, Hadoop, or Kafka, or something like this, so a partitioned cache is that you take your big data set, you divide it into a few pieces, and each piece is stored on a single box. So let's look at the JVM2 and JVM4, for instance. So what it says right here is that if you look at A, B, C, and D, so there's only one primary copy on each of the nodes. So if we got rid of the backups, when we just have a partitioned cache without backups, we can't tolerate a node failure, because each node stores a small piece of the data set. When it goes down, we're losing, for instance, if JVM2 goes down without the backup, we're losing the part C. The backups are replicas. So if in this example, we have just one replica. So each node holds a primary copy of one chunk of data and then a backup of another one. This way we can tolerate one node failure. You can increase the backups to the number of what you can tolerate. I mean, how many nodes can go down. So if you really want to have crazy solution, you can use the replicated cache. That means that a single node holds the whole data set. But in real like big data solutions, I don't think it's doable, because if you have terabytes of data, it's really hard to get it into one box. So replicated cache would be mostly used, like we used it just for small data sets that are kind of lookups or dictionaries that we store on each node, just for performance reasons. But partitioned cache is something that is the best in that picture, I would say. Yeah, maybe I'll go with the next slide and then we can show some code examples. So the partition assignment. So each cache in Ignite is built of 1024 partitions. And partition is a single unit of distribution. So when you have two nodes and a single cache, each of them will store 512 partitions. When you store some data into the cache, then your client needs to know where to store that data. And this is one of the problems in distributed systems. Like if you have a single node in your database, you just write to it. But if you have a distributed cluster, like you have to know where to go. So has anybody ever seen that picture that I put over here? Yeah, Alex, I know. So this is something used in Cassandra DynamoDB, which is called consistent hashing. So this is how you represent like nodes on the ring, which node should store which data. And this is a kind of sophisticated algorithm. Ignite doesn't use that well, you can implement it yourself, but it does something called rendezvous hashing. And rendezvous hashing is really simple. So let's say that we have just 10 partitions, and the partitions are indexed with 0 to 9, and each node has its own ID, which is generated on some host name, IP, and some other things that are pretty unique on your even box or in a cluster. So when you concatenate the node ID with the partition ID, and you generate the hash on all of the nodes, well, you know that you will get all the same values on all of the nodes. So the biggest hash wins. And all of the nodes immediately know that, okay, node 1 should have partition 2 because it has the biggest hash value. So you don't need anything like a distributed quorum or Zookeeper or other crazy solutions to figure out the leader for a particular partition, because it can be simple. It's not the most optimal value, because consistent hashing solves some other problems, that it tries to minimize the amount of data that you have to move when a node dies. Rendezvous hashing doesn't do that, but it's very easy to implement, and it gets very fast, so that when one node dies or joins the cluster, you immediately know who's the leader for each partition. So let me show you other trivial code examples, but just to give you an idea how really simple it is to work with Ignite. Let's kill those two guys, let's run 2 servers. 1, 2, okay. We should have the topology set up soon. Yep, so like a cache put. We want to put something into the cache. It's really simple. Like when you get an Ignite instance, I wrote some trivial code. It looks like this. When you get an ignition start. So this is the client, so we have a client property set to true. And let's go back to where I was, cache put. So on the cache, you can do a lot of operations. One of them is put if absent, but if you look at the amount of operations like clear, contains, looks like map for each, not really effective, but get with transactions, really tons of different functions that you're going to call methods, anyway what you want. Okay, come on. Oops, sorry. Yeah, so we're just putting 50 elements into the cache. Let's just put it. So yeah, it's not very sophisticated, as I said. Then finished. Let's do a cache get. Cache get is not much more difficult, I would say. So we just iterate over, let's say 10. We can check if a key exists, and we print something if it exists. I mean, no rocket science yet. Where is it? yeah, so it says that, yeah, there is a mapping, because when we created the objects in cache, we put under an integer a string with that integer, so that's cool. Let's leave it for the moment with the caches. But when we go to the next component, I'll present you some more sophisticated code in terms of the compute grid component, because I believe the combination of caching and the compute grid is crucial in thinking why we chose Ignite and why I think is interesting. So the compute grid is a compute platform. So it's not like I said, you have Cassandra or you have Elasticsearch that you can store some data, but you can also run jobs like distributed closures on your cluster. You can have the call and run methods like you have the runnable and callable interface in Java, depending if you need a result or not. You can have a distributed executor service. So we use it like the normal executor service, but the jobs are fired around the cluster. So if one fails, you get the fault tolerance and it's shuttled on another node. And you also get load balancing. So when you fire 10 jobs on the executor service, they will go usually in round-robin fashion around all the nodes, so they are all loaded the same way. You also have this thing called MapReduce and forward join processing. And I think this is the thing that I should mention here, because when you saw that UI I was presenting, when I was typing the attributes and the numbers were changing, this is the mechanism we use. So if you think about the searching for the attributes, if you use Elasticsearch, all of the attributes would have to be indexed. So that means there would be like 8,000 or 10,000 fields that were indexed. You would have to change the indexes every time you load new data. We did it a different way. Like we picked Ignite, we have our own storage mechanism in memory. Like we did it pretty efficiently, I would say. We store the attributes as bit sets. So just a single attribute should be a single bit, so we limit the memory usage. And we do a crazy thing, which is like brute force search for the data. So every time I type an attribute, there are jobs run against the whole cluster, and each node processes its own partition of the data. And then it goes back with the response. So that MapReduce is like the Hadoop MapReduce. You bring the job local to your data, you process them, you do all the crazy work, and then you come back with the result. So we're not indexing the data, having some aggregations or anything like that. Every time we do a brute force, and that's why we need the compute engine to do the business logic. And the collocation of compute and data, which comes with MapReduce. In Ignite, you can even pick a key value and say, hey, do some job for that key. If you, I don't know, you want to, let's say you store some images and you have an ID of the image and you say, I want to compress that or uncompress, you don't have to know what it is. You let Ignite figure it out by the key, by your ID, because it knows where it's stored. Before we go to SQL, let's present the compute example. So this will be more difficult, but not that much. So I have another client, and I'm going to call the broadcast method. So take a look at this line. So from Ignite, you get your compute engine, and I specify that I want to run on data nodes. Data nodes are the servers, and I mean that I want to run on data nodes which hold the test cache. And for all of those nodes, I will broadcast some job called how many keys. Yeah, I know this code is ugly, but it can be more beautiful, I guess. So what it does, let's go through that. Remember that this how many keys is called on the server side. So we get a cache instance, this test. We pick only local entries called the primary, like we saw in the picture before. So we only get data that is stored on the local node as primary. So we only want to process the data that belong to that node. We just get an iterator, and then we do a count with stream Java 8 streams. I just want to count the number of keys the node stores. I'm going to print it and return to the client. So let me run that this piece of code. Yeah, it should be finished by now. Yep. So basically 2 jobs fired against those 2 servers that we run, and it says that node, this one starting with 4C, has 30 keys, and the other node has 20 keys. We put 50. Well balanced, because like the hashing works this way that it just assigns to some partitions. So if we keep increasing the number of keys, I guess this will be more uniform. Let's try to do another thing. Like when we have one server, let's just kill it and run again the client code just to see how many entries are on which node. Okay, so now we have that this single node that is alive has 50 keys. So we killed one node, but because my config says that a test has one backup, and we can lose one node and we still have all data. So when I killed that node, there was an even sent, or the server that is alive figured out that the other is dead, and said, okay, I need to recalculate who's the leader for which partitions. And it came obvious to him that he needs to be the owner of all of the partitions. So that's why we have all the data available still. Another example that I can show you with the compute grid is the executor service. Let me run again the second server. Yeah, when I bring it back, let's use our previous code just to see how many keys are stored where. I believe that it's going to be again 20, 30 or something like this. Because this whole process when a node dies or joins is called rebalancing. It's pretty fast. Yeah, so it's again, we have 20 and 30 keys on the 2 nodes. And the other thing that I wanted to show you that I just mentioned is the executor service. In this example, what I do is I get an int stream of 3 numbers, and I do a very ugly Java code. When you have a lambda that you need to serialize, you need to write that crazy thing over here. So basically on the executor service, I execute the print lambda, and it's gonna print executor service with the number. And what's interesting here that the executor service takes from a pool of servers and the clients as well. So it might be the case that when I run those 4 or 3 tasks, that one of them will be executed by the client, another one by the first server, and another one by the second server. Let's see if it works like this. So this client just terminated. You see that it executed that lambda because it was part of the executor service pool. It's going to be the same with the others, I guess. Oh, this one got 2. And there's another one. Another one just put 1. So it is load balancing. You have failover when the node dies, it's taken out of the pool. That's why you need those topology changes you see over here. Since we keep it running for quite a while, the number is version 16. We have 2 servers and 0 clients. So that's the compute engine part. Let's go to something more or less interesting, depending on how you look at it. So I showed you the API for the caches. Yeah, you have to write some code with the API to make it work. But it also supports, Ignite supports SQL on top of caches. So basically it's a horizontally scalable and fault-tolerant ANSI compliant. It has ANSI compliant SQL engine. So you can run queries against your cache, and it supports most of the standard SQL and DML commands like select, update, insert. You can do joins, but then you have to realize it's a distributed system, so it has to exchange some data. And as far as I remember recently, you have to specify explicitly that you want to do a really distributed joins. But if you remember that I talked about collocation of data and processing, you can have something that joins that are run on a single node. I mean that the data is put into the cache so that it's collocated one table or one cache with another. So when you do a join, like each node only processes the keys that belong to this particular node. So this is interesting, and I'd say it's a pretty sophisticated thing. You can have indexes on single fields as well as on group of fields. So it's like, let's say, standard database. Why we didn't do that with the Ignite SQL? It's not as performant as what we did. And if you think about indexes and fields, you have to define fields with indexes, so we need to know the schema up front, but we did it the other way, and we don't have the schema. Like if you remember when I was talking about the bit set, so if you have a single bit set for all the attributes, it's hard to define it in Ignite that, oh, this bit is an index. I'll show you how you annotate some objects to have indexes and how it works in a second. So it works with JDBC, ODBC adapters. And another feature that it has is Geospatial Support. So you can run some queries if an object is in that area or that area. I think it has to, you need to import some license because they also use some external library, but I haven't played with that, so don't want to talk about it. So let me show you like a piece of code with the SQL thing. I don't really like it, but I'll just present you what it is. Another piece of nasty code, but not this one, sorry. I want to show you this person class that we store in the cache. There's nothing specific about it apart from the fact that it's serializable because we store it in a cache. But the way you let Ignite know that you're going to be using SQL thing on top of your cache is that you put like a query SQL field. That means that this field will be available for the SQL engine. But if you put also index equals true, that means you're going to be using Ignite as SQL indexes for that field, and you can search by that field. So I have a few fields, ID, name, and age, and some salary that I have a descending index. And in the SQL example that I want to show you is basically we're going to load the person cache. Loading the cache is not crazy. We're just going to put three people over here, person 1, person 2, person 3, with some attributes, the age and salary. Then we're going to search for people by salary and age. So we want to have people who earn more than 1,100 zlotys, dollars, yens, or whatever you can think of, and are older than 30. And then another example that I have is that you can run a select with some SQL functions that I said it supports, like concat. And you see over here that the way we use the cache is pretty similar, let's say, to some JPAs or Hibernate libraries, where you just type a query in a string and then let Ignite figure it out how to do that. So let's just run it, or maybe let's focus on the details. So for the find by salary and age, we use a SQL query. We tell it that it's a person class. We define salary greater than and age greater than. Then we do a cache query. We just bind the variables salary and age. We get a cursor, we iterate over it, and we print it. Not a big deal. Same thing happens here. You do a SQL fields query, you provide your string, then you get a cursor again, iterate and print. So let me just run it and just see if it just works. It should. Yeah, so like we look at this thing, like person 3 is over 30 and earns more than 1,100 something, some currency. And the select concat is basically here, person 3 is 35 years old. Yeah, it's not really interesting, but I'm just showing you the capabilities that it has. If you really need to store some data in memory to be faster than in a traditional database, I believe it can help. And it has fault tolerance, high availability built in, so I think it's a good solution. But it's much more than I was showing. I told you that I'm going to just present the data grid, the compute grid, and the SQL grid. It supports this distributed messaging, so you can have like publish, subscribe, and peer-to-peer messages. You can have distributed events, and this is how the topology works. They send events between each other when they join and they leave. You also have a set of distributed structures, like if you look at the names over here, they kind of remind of what you have in Java. You have concurrency, but these are distributed. So yeah, they can be nice if you need some sophisticated distributed counters, for instance. And Ignite also supports a lot of plugins for streaming. I mean that when you want to store some data from Kafka, Storm, Flink, there are out-of-the-box connectors that you can stream your data into Ignite, into your caches, and have some retention policy, either for the number of the objects or timing policy that you want to get rid of the objects. So there's a lot of mechanisms built inside. The new things, like we started with Apache Ignite 1.4 2.5 years ago. It has changed a lot. Right now, the latest that I was showing to you is 2.6. It really keeps evolving very fast, but I just listed some of the new features that they have, and they're trying to extend this technology to fit even more needs. So like, there is a pretty rich library, well, rich, maybe not that rich, machine learning library. I've never used that, but I'm just listing that if you're interested. I think they started that like a year ago, so I wouldn't expect tons of algorithms, but I don't think it's much worse in terms of the list of algorithms supported by the MLlib of Spark or something else. Like, it's hard to compete with TensorFlow right now, I guess, but still, if you need something simple, it might work. And I think the interesting piece is the genetic algorithm grid, but I won't talk about it because I have no idea how it works. So as I said, there are more and more features, keeps evolving very fast, and that's why I think it's an interesting component. Some useful links that I have, if you're interested in that and you like the idea of this in-memory data grid, is the Apache Ignite README IO docs is just the documentation about the specific version. Your blogs, this is where they describe some of the mechanisms they implement. This is interesting, like they describe how they do distributed joins, or how they sort out different problems like split brain scenarios. The interesting thing is the performance benchmarking, because this is where I see the whole competition between Hazelcast and Ignite. Like, both of them try to show that they're better than the other. So this is a nice one. And the last one is Cloud Grid Gain Com. This is if you want to experiment with Ignite and you don't want to download anything to your box. You can go sign up over here and use the beta version right now to get a cluster of Ignite nodes. And what's interesting about this link is that our guys, our DevOps, helped the Grid Gain company, which stands behind Apache Ignite. Grid Gain Enterprise is the commercial version of Ignite. We helped, the company helped Grid Gain with the deployment into the cloud, like AWS or Google Cloud Platform. So our guys helped a bit, so that, as I said, it's pretty interesting that we have good cooperation with them. But this thing happened like 2 or 3 months ago, and just recently got aware of that. And other in-memory data grid solutions that I could find that you can sometimes compare is, of course, Hazelcast, it's open source software. Apache Geode is another in-memory data grid from the Apache Software Foundation. I don't know the details how they differ, but I know that Pivotal Gemfire, which is a commercial tool, is built on top of Apache Geode. So they must have added some features. Another two is autocoherence and gigaspaces. I don't know if you ever heard about it, but just for you to remember. That would be it from my side, and I guess there will be some Q&A session.
Bravo, first of all. So, do you have any questions to Bartek about Ignite?
There are some.
what will be your reasons not to use Apache Ignite?
Apache Ignite, not to use it.
Yeah, where are you can actually shoot you in yourself in the foot trying to put it into the project?
Let me try to answer that from a different perspective. There's some things that are really crazy about Ignite that I hated. Like, I don't know, Vlad is here. No, he's not here when we started that, so I was the first person. Then Vlad joined me and I told him that, hey Vlad, there's something wrong with logging over here. And Vlad spent like a week searching for what's wrong, and it turned out that Ignite has its own logging layer, and I spent another 2 weeks to plug in some 3 libraries that would work. So that's well, it's important because this is what you start with, and it's not great. Where I wouldn't see that working. Well, if you think about the fact that you go with Apache 2.x something, and you don't have the heap, but just the off-heap memory, and you want to do something like we do, that you want to do a brute force search with every query, I'm pretty sure that, well, I know that the off-heap will kill you, because every time you do your query, you have to serialize and deserialize your data from Java, the off-heap to your Java heap. We did some tests, and for single gets and puts, it's nice, but it wouldn't work if you wanted to do our way. Ignite, not the enterprise version. I think it doesn't have like multi-DC support. So if you want to go with a cluster that has full HA between 2 regions, then you need to use the enterprise version. Like, the monitoring out of the box is not great. I showed you Ignite Visor. Alex will show you something else that was added not a long time ago. Initially it was really poor, so we had to build up our own monitoring. What else? With the open source solutions, you cannot mix different nodes coming from different versions. It's going to tell you like 1.6 and 1.8 is good. No, we're not working together. I'm just going to die, because apparently they have some differences in the underlying protocol, but I don't believe that. I think it's just some fix in the code that just compares the version and tells you, no, we're not going to work by the enterprise version, and this is where it works apparently. What else? I don't know. Depending on the use case. Like, if you gave me some specific use case and you asked me if I gave it a shot with Ignite, I would probably do that, because what I learned basically is that I don't say no. Like, I also tried to imagine the solution with Cassandra or something else, but then I thought it just doesn't fit. Like, yeah, you have a fast key value store, but you don't have the processing, so you're limited to just gets and puts. So you could theoretically put under each attribute the list of people that match it, but then you also get into the problems that a single key in Cassandra has to be smaller than some amount, and you never know if you're gonna push all your data into that. So I think it depends on the use case. I believe this platform is pretty rich, so there are a lot of solutions that you can build on that. In a way, you can compare it to Redis with the caching. On one hand, people will tell you that Redis is better because it doesn't have the JVM underneath, so there's no garbage collector and it's going to be faster. And I believe it is faster. But the richness of Ignite comes with the other components. And we also had problems with garbage collector, but we somehow fine-tuned it and it was okay. So it has its problems. The API sometimes is not that great, I would say, but in terms of functionality, it's pretty rich. Maybe Alex, you know something that you don't like.
I would probably mention just transactional data. If you want distributed transactions, and you'll be the same problems for any distributed systems.
Well, yeah, distributed
log.
Yeah, like what we had to do is, like, when we were, the other scenarios that I mentioned is that when you do the whole filtering and you see, okay, this advertising campaign will not cost us tons of money, and you want to export the data, we wanted to limit the number of exports happening concurrently. So we said, oh, maybe we should use some atomic integer or some distributed log. And like if you get into distributed systems more and more, especially those built in Java, then you figure out that there are some crazy scenarios going on with distributed logs. Because let's say that one node has a log and it believes it's okay. Suddenly the GC phase kicks in. It lasts 30 seconds. This node doesn't respond to any others, so the others think this guy is dead. So the log is free now. And suddenly the guy that took the log just wakes up and says, hey, I got a log and I'm going to do something else. And then he gets, yeah, you go away from here. Like you're not having the log anymore. So this is where it gets hairy. But it's a standard problem in distributed systems, so I would definitely try to avoid such things. But like my experience with this technology is pretty good. That's why I wanted to talk about it. Because it's also fun. I think that you can code a few things, think about how it works, and then just put some annotations and let it do the work. But then when it fails, you don't know what's going on. So, yeah, I don't know if it's a good answer for your question, but I did my best.
Okay, any other questions?
I knew that. That's why he came here for.
Question about the cache and the application which you were showing in the beginning. How do you update the cache if data which is behind is getting updated? Do you reload it from scratch, and what is the amount of data, and how long does it take to reload?
Okay. Yeah. So the amount of data I told you, like we had 45 nodes. Yeah, 50 nodes, let's say, roughly 40 gigs of heap size and 36 gigs of heap size constantly occupied. So that's around 2 terabytes of heap memory. How we update the data? So there are two scenarios. Some of the things we update on the fly, but when we have to do the change of attributes that I was talking about, the 10,000, we reload the data completely. So we have like a scenario where, like, the initial approach was that we were reloading the whole data, and it took a few hours. But then I think recently you guys optimized it, and it's because like the deal with the other systems is that they export the data from an MS SQL database. It takes a whole night and it creates some files on S3. So there's no way you can speed up loading from the S3 objects. Like we try to partition those files, and each node loads a chunk from the S3 files. So right now we do some pre-aggregation, from the files, and the load takes, what's the time?
10 minutes.
Yeah, so right now the load takes 10 minutes. You wanted to know about the cache updates. Okay, so there are multiple ways you can make sure either your data is consistent or available. When you do a put to a cache, you can specify if it's a synchronous update or asynchronous update. You can also specify if you want to have all of the replicas to answer immediately if they store it, so that you keep consistency, or you want to do the fast way, just store it and go back to its own job, and then in the background they're going to replicate the data. Is that okay? I passed. Okay. Any other questions?
One more.
Good.
So is there an interface in Ignite to read the data from SQL database directly without the file in the middle?
That's a good question. I can't remember that one. I think that there is some. Let me just open it. There is some loader interface, and I think there is a basic thing. Yeah, I can find it in a second. So, if you're really interested in that,
Repeat the question.
repeat the question.
Yeah.
Tomek, can you please repeat the question?
So in the scenario which you were describing, the guys are uploading some data from MS SQL or into the file,
Mhm.
and then you're loading the files into
Yeah, this in
So I
memory.
was wondering whether the cache has capability to read the data directly from the
SQL database.
database.
I remember the loading code was written quite a long time ago, and there is an interface for loading, and I think there was something about SQL, but when Alex starts his talk, I'll find it.
Yeah, never mind.
Now you don't care, yeah. You wanted to ask that question that I can't answer, okay, you win. Any others that I can't answer?
Yeah, maybe the last question,
Very good.
because we're tight on time.
No.
No questions.
Okay, thank you very
so
much.
final bravo for Bartek. Okay, so I think let's take a couple minutes, maybe 3, maybe 5, just to, I don't know, take the last bite of pizza, just maybe some drinks.